Okay, so the questions I want to talk about are 16 and I believe 17, and those should help you. Tonight's homework is going to be a couple of those other ones up there. It's not going to be all of them, but that should help you then address the questions that I give you in your homework that are similar to. And then we'll go to some of the story problems on the second page and do the same thing. Okay. So addressing number 16. How are you going? You can tell me how you're going to do it.
Yeah.
What are you going to do?
Well, so triangle on the left is 45, 45, 90. That means W is 82.
Okay. So 45, 45, 90 over here, right? And that's something, guys, I'm not saying you have to, but I'm saying that that's a really, really good practice to recognize angles and say, if they're special angles, let's use that special approach, right? And I can generate that 82 real quick. Now, is there a different way? If I look over there, is there a different way to find that? Is this the opposite side? 45. Is this the adjacent side? What uses opposite and adjacent? Tangent. So if I go tangent of 45 is equal to W over 82, cross multiply, give me W equals 82 tangent of 45. What do I get if I type that in my calculator? You get 82. Okay? Meaning that tangent of 45 is 1. Okay? Now, you can do that. That's great. But if you do it that way, you're missing out. Okay? You're missing out on the template and the understanding of what's going on. You're trying to be almost robotic and just say, okay, I've done this before, so I'm going to copy these steps and do this algebra, hit enter, get an answer on my calculator, write down, right? Where there's little thought in that process. Okay? And if you did that process, did that take about 3 or 4 times longer than what Alex did when he said 45, 45, 90, WW82? Mm-hmm. All right, so that's the benefit of recognizing those special relationships. All right, so now, what are you going to do?
Oh, well, since the W is 2 and the Z is what's not that hypotenuse.
Okay.
Oh, wait, no. I was looking at it as a basic.
Okay, so.
But now you.
Okay, so Alex is, initially he was looking at 30-69 triangle. Now, is that close to a 30-69 triangle? Okay. Okay, so now I'm going to do trigonometry. But if that's pretty close to a 30-60-90, isn't it? So shouldn't that Z value be pretty close to 82 radical 3? Okay, it's probably going to be because 28 is less than 30. Okay, meaning then that opposite angle is going to be 62 and not 60. That Z value that we find out using trigonometry, I think it's probably going to be bigger than 82 radical 3. But it's going to be in the same ballpark. Does that make sense? So that idea, that logic, and I want to go back here in a moment and talk about another question from previous questions in the assignment to help myself out in regards to maybe I'm uncertain about the answers, but I'm really good at really good at special right triangles. Maybe using to understand that that's close to 30 could help me realize whether I'm doing the trig right. Does that make sense? I'll explain it again when we get to another question. But we do have to use trigonometry here. We have to go that side, that angle produces this side, which would be what to it? Opposite, and Z would be the adjacent. So you're going to use a tangent. So say tangent of 28 is equal to 82 over Z, right? Cross multiply, you get 82 equals Z tangent 28, right? Now what? Divide, right? I'm going to divide both sides by tangent 28. So I end up getting Z equals 82 divided by tangent 28. And the reason I wrote that over here is because I want you guys to see something that might be of benefit in regards to being efficient with these. What happened from the red box to the green box in regards to solving for Z here, Trey?
82 is on top of the tangent 28.
Right, so the Z and the tangent 28 just flip spots, right? Does that make sense, everybody? And that's going to happen every single time you do this. If you ever get your denominator in your ratio to be a variable, then just a singular variable, because it's going to change a little bit in the next question. If it's just a singular variable, then the left-hand side and that variable interchange spots, and you automatically then solve for Z that way. Okay, that's because I'm going to cross multiply, get 82 equals Z tangent 28 every time. I then divide by that tangent 28, okay, to isolate z. So maybe a quick shortcut to save you about maybe 10, 15 seconds. Type that in and you get 154.2. All right. Some people earlier in the day were doing this, and they're saying, they said, I'm going to look tangent 28 equals W over Z. And they wrote that. Is that right? Is tangent 28 equal to W over Z? Do you guys agree with that? But that's where they started, and what's wrong with that? I can't solve that, right? Two variables. And then they go, how do you erase it? And they erased it, and they go through over here, and they find 82, and they say, okay, well, now they go tangent of 28 is equal to 82 over Z. 2. But I just write down the same equation that I previously had? All right, so the issue that I've had in the past is that occasionally somebody will do that, they'll write the correct relationship here, know they can't solve it, then erase it, go somewhere else in the problem, start working through the problem, finding like that 82, but then when they want to start solving for Z, they can't come up with that equation that they initially had. All right? And that happens more frequent than you would think. So my suggestion to you, if you know the relationship that you're writing down is accurate, if it's true, don't worry about erasing it. I mean, the worst it's going to do is take up a little bit of space on your paper, right? Okay, if you don't end up using it. Keep it, because then chances are you're probably going to use it. Okay? Even if it's not something you can use right away. Okay. I'm going to go back to question number 3, I think it was, real quick. Look at that triangle. What's that really close to?
45.
A 45, 45, 90, right? If that was a 45, 45, 90, x would have been what? X would be 50. If we go through the trigonometry here, we found x to be like 48 something, okay? Does that relationship between knowing that if that was a 45, 45, 90, that would be 50, help validate that when it's 44 degrees, that it probably is 48 units long, okay? And that's the idea that I want you guys to, that's a problem-solving technique to provide validation on processes that maybe you're uncomfortable with. Maybe I'm not 100% certain on my tangent, sine, and cosine processes, but I'm good at special right triangles. Okay, so I can use my knowledge of special right triangles in approximation to help provide validation for my trigonometry, my sine, cosine, tangent stuff. Does that make sense? And you can do that everywhere in mathematics. There's a lot of situations where that's present. All right, so let's do 17.
Can I teach it? No. You know how to do it.
What are you gonna do?
Well, there's 45, 45, 90, and a 36, 90.
Okay, so you've got two triangles here overlapping each other, right?
Yeah.
So you're seeing this.
Yeah. Do you want me to answer for W?
Sure. What's W? 160. Does everybody see that W is 160 because of that triangle? Okay, that's special right triangle. We've been working on that for a while now, right? Could I still have said tangent of 45 is equal to 160 over W? Or I could have done tangent of 45 is equal to W over 160. Either way, it's going to work. Okay? Okay, that's great. 160, so now I do. Okay, so here's the question at hand. Z is part of, oh, that's a terrible triangle. You just told me that this was 160, right? Yeah. W goes up to about that point right there, correct? So that's 160. And then this distance here is Z, right? So if I'm going to, do you still want to use special right triangles? Yeah. Okay, so across from 30, this is N, right? Across from 60, that side there is what?
Wait, what?
What's always across from me 60 degrees? It's the N radical 3 side, right? But what's our N? 160. So do we see how that distance right there is 160 radical 3? Is that distance, though, what we're looking for Z? Z's that right there, correct? How do I take that 160 radical 3? What do I do with that to find Z? Okay, so 160 root 3 minus 160 is going to give me that Z. Okay, and we got to do that problem solve, that segment addition, segment subtraction to help us figure that out, right? Not the only approach, okay? And I'm going to show you something here that the reason I'm showing you for two reasons. One, it gets you the same answer. It looks completely different. But two, it's going to shouldn't introduce, because we should know this algebra, but it's going to bring to the surface some algebra that maybe we're not 100% confident in. And it's going to be important for us to be able to do this in the next couple months. All right, so you told me that this was 160, right? Okay. If I'm just focusing again on that big triangle, so let me get rid of this line here. Get rid of that 45. I'm going to that triangle there, and I want to use trigonometry. I should have that capability. Looking at that angle right there, what would this side be? Opposite. So I'm going to say tangent of 30 is equal to opposite over, now this side would be the adjacent side, right? That's why I chose tangent. What would you call that side there? 160. We don't know, because I want to use trigger, so I'm approaching this like I don't know it's such a right triangle. So you're right, it's 160 plus Z. Okay? Now, what is different about this than any other one of these equations we've done? Yeah, we've got a sum here. Usually over there in all the questions 1 through 12 in last night's homework, that was not a quantity, it was an individual value, right? Okay? Now, we still approach it the same way because we got a proportion here. So I'm still going to take 1 times 160, and I get that. And now I'm going to take this times that quantity. Okay? Now, I've been doing this today, and I think this is helpful. If I type in my calculator tangent of 30, it's 0.577. Okay, so these two proportions are the same thing, except for this one's the exact values. This one's rounded to 3 decimal places. Does that make sense, everybody? What would you do here in this one that's rounded? You cross multiply, so it's 0.577. What would be the, in order to actually multiply here, what's the terminology we use there? We distribute, right? Okay. So the same thing is going to happen up here. I need to distribute this tangent of 30 to both these numbers. Now, I want to write it this way. Tangent of 30 distributed to 160 is actually going to look this way. 160 times tangent of 30. Does that make sense to everybody? Then the tangent of 30 times z is going to look this way. Z times tangent of 30. When you distribute, when you start multiplying trigonometric values times numbers or variables, we usually put the trigonometric value at the end of that product because later on you're going to get to courses in which, right, we've been writing tangent of 30 that way, but a lot of textbooks don't use parentheses. So if I just write tangent of 30 and then write 160 after it, a lot of people are going to interpret that as the tangent of a 30,160 degree angle. Where if I put the 160 out in front, now there's no question of what that angle measurement is. Does that make sense to everybody? So a lot of the times the structure that we use in writing these things and where certain coefficients and certain multiples go is because we want to try to eliminate confusion as much as possible, which in retrospect sometimes creates more confusion. Okay? But that's the reason we do that. All right, so I want to do something real quick here. If I were to evaluate these, because I think paying attention to the fact that this equation, this blue equation in rounded values would be something, I think this is like 90, I think it's 92.3 or something like that, 92.4. I don't really care how accurate I am on that. Plus then, tangent of 30 is 0.577.
Yeah.
Okay? If I was looking at that red equation, what would you do first? So this red equation is exactly the same thing as this blue one, except for it's rounded, right? You would subtract 92.3 from both sides, right? So that 92.3 is analogous down here as that exact value, right? So if you subtracted it from both sides up here, what are you going to do down here? They're the same equation, so don't they be solved the exact same way? Okay, so I'm going to subtract 160 tangent 30 from both sides. Now when I do that, on the left-hand side, because the only time that I can subtract numbers, okay, and actually do, like right here, you would actually rewrite that, correct? Okay, you would write that as about 67 something, correct? And condense them. But when I have 160 minus 160 tangent of 30, I'm not going to condense those because it's not going to be a nice, neat number. Does that make sense? Because that 160 tangent of 30 is going to probably be irrational. 160 minus the irrational number is probably going to give me another irrational number, right? So it's not nice to do that. We're just going to leave it as the implied subtraction here. And then this equals z tangent of 30. Okay? So now, what we'd be looking at in regards to a red equation, I'm not sure what that, let's say 67 ends up being that different. In that red equation, what would you do next? Divide by 0.577 right, to both sides, right? What's that 0.577 actually refer to? Yeah, it's the same as that tangent 30. So if you divide it by 0.577 here, you better do that down here, but you're going to do it with a better version of 0.577, right? So those are going to cancel, leaving me just z on the right-hand side. And then I'll have 160 minus 160 tangent of 30 all over tangent of 30. No. Right. And so these tangent of 30s can't cross out, and this is the reason. Remember, tangent 30 is just a number, right? So let me ask you this. Would you ever take 160 minus 160 times 2 all over 2, would that equate to 0 ever? Would you cancel those out? No, because 160 minus 320 is going to be negative 160, right? Divided by 2 is negative 80, correct? If you canceled those out, what would you end up getting? 0, which is not the same thing as that negative 80, right? So that hopefully proves to you, because that's always a good question, that always proves to you, hopefully, that even though you see that there and there, because there's other operations occurring up here, primarily the subtraction, you can't just cancel those. So if it was just this, so 160 stays. No, because it would be something like this. It'd be negative 160. What I have here, 2 and 2. You're still not going to want to do that because now this is going to be negative. Come on. Cursor died. Hold on a second. There you go. If you cancel those out, you'd end up with 160, right? Does that make sense? But if I go through the order of operations that we're supposed to, I get 160 minus 320, so it could be negative 160 up top. And on the bottom, it'd give me negative 320. So that goes to 1/2, right? Where if I just cross those out, it leaves these 160. 160 and 1/2 are not the same. So my suggestion to you guys, if you're ever doing algebra and there's variables and maybe irrational numbers like tangent 30 and that kind of stuff present, and you're not sure of whether they cancel out or not, develop something with just numbers, just like whole integers, okay, that mimics what's going on here. And what I mean by mimics what's going on I'm going to choose a number 160. Okay, maybe I make it 5. And then this 160 is the same thing, right? So I make it 5 again. And then tangent 30 is something different, correct? But it's being multiplied together, so maybe I make it 3. And tangent 30 on the bottom, well, that's still the same thing as that, so it's got to be a 3 again, right? Does that make sense? So I kind of make those weird substitutions, and now I should be able to, because of order of operations, know that that's actually 5 minus 15, which is negative 10 over 3, right? Negative 10 thirds. And my initial thought was, well, I could just cancel those out. Well, does that give me negative 10 thirds when I cancel those out? No, it gives me 0, right? So negative 10 thirds and 0 don't equate. So that process of just being able to cancel those shows me that that's erroneous. It does not work that way. Okay? That is one of the things that people struggle with the most, is learning when to cancel things out and when you can't. When you've got addition and subtraction in your numerators, you got to be very, very cautious on how you cancel things out. You can only cancel things if they're common factors. Okay, so you got to have multiplication. Okay, so now here's the thing. Look, we already did this. That took some time doing that, right? Probably not the preferred method, but let's see what that answer looks like. We had 160 minus 160 tangent of 30 divided by tangent of 30, right? Give me that number right there. Previously, didn't we say that that same distance could be found this way? Are they the same value?
I got 0.
Okay. Now you got 0 on your calculator, right? I'll show you why, because this is important.
I got it.
You got 0 because you did this. So think about this, guys. And this is why I don't like the TI-83s and 84s, okay? Until you understand how they work. If I neglect my order of operations, so I just write 160 minus 160 tangent 30, then when I know I got to divide, I divide. And PEMDAS is going to tell me, think about this, if I didn't put parentheses there, I write 160 minus 160 tangent 30, divide tangent 30. Order of operations is going to say go do 160 tangent of 30, multiply those together. Get that sum. Now take that sum and divide it by tangent of 30. Well, that becomes 160. And it's going to then take 160 minus 160, which gives me this 0. Does that make sense? And it's really hard on my TI-8384 because what you're going to do on your TI-84 is this. This is exactly how you would type it in. You'd go 160 minus 160 tangent. It opens the parenthesis, you close it, and then you hit the division sign, and then you type in tangent of 30. If I type it in that way on my TI-83 or 84, or even those smaller handheld ones, if you did that, it's going to actually evaluate this way. Does that make sense? Well, that's not the way we wrote it, correct? That's not the way we came up with it. So to fix that, I need to put a set of parentheses right there, and that will fix it. Okay, so that will fix it, and now you see that's going to do that numerator. It's going to calculate that numerator correctly first, and then divide that numerator by 30 to get the right answer. And that's the number one thing that I hate about your calculators, when we don't learn our order of operations real well in Algebra 1, and we don't learn how the calculator is programmed to use them real well. When we get to this class, we get to college algebra, we get to trig, we get to calculus, we get to all those other courses. We might be typing something. We might have done everything by hand correctly, but when we type it in, we don't know how to type it in so that the order of operations are followed correctly, that we get a wrong answer, even though on our work, everything's right. Does that make sense? I would say of my college algebra trig students, we take our tests on paper and pencil. I would say of the questions that get missed in those classes and that they don't get all the points awarded, I'd say 50%, maybe even more, of the questions are wrong because of grabbing the calculator and typing something in wrong. They got all the work correct, but then they go from the work to the answer, there's a misunderstanding. Does that make sense? Which for my class isn't bad because a lot of times I look for that statement right before the final answer, and if that statement's right, I give them points. Okay? But on the ACT or in another college class or something like that, different professor, they're not going to do that, okay? So it's very, very important for us to understand how those things operate and how we can use those to our benefit. All right, so your homework tonight, guys, this question is going to help you do 15. So 16 is going to help you do 15. 17 is going to help you do 18. I'm going to give you a couple out of here, so I want to talk real quick about how I can help you with number 20 is going to be your homework question. I want to do 19 to help. Does anybody know what the grade of a road is?
Yeah.
What?
Okay.
I heard somebody say something. So, what'd you say? It's a slope, okay? Grade of the road is the slope of the road, okay? So here it says the grade of the road is 7%. You guys, if you've ever traveled, been through the mountains, you might see a warning sign that kind of looks like this. Got a little triangle there, and it's got a car on it. And that car is going down or up, but then it says up here like 7%, and it'll say over like maybe the next 3 miles. Okay? What that means is that for every, because it's a percentage, for every 100 feet that you travel that direction, you are going to gain or lose elevation, whether you're going up or down, 7 feet for every 100 feet. Does that make sense? So when they say that my grade of my road is 7%, that means this is 100, that's 7. Now, it doesn't have to be 100. This could be 50, and this could be 3.5. This could be 10, and this could be 0.7. Does that make sense? Okay? It's just easier to do 100 feet and 7 feet.
That's a terrible car.
Okay? Now, the question is, what is the angle of elevation? So the way I view this, guys, is I've got my road here, right? This is my blue road. It's flat, it's horizontal, it's on the ground. And this is going to be an overpass. Okay? Well, if I'm walking next to the overpass, think about going out here on Slabtown. If I'm walking next to the overpass, I'm going to walk over the top of I-75, right? Well, if I walk up the overpass, the actual physical road is going to make an angle with that path that we call the horizontal that I would have walked if I would have walked across 75. Does that make sense, everybody? That's what they're asking for here, what that angle is. When they say, what is the angle the road makes with the horizontal, we're looking for this X here. So what is 7? Opposite. What is 10? Adjacent. So what's trig ratio you going to use? Tangent. So tangent of X is 7 over 100. Not 1,000, over 100. So now X would be tangent inverse of 7 over 100, right? Now, like I said, it doesn't have to be 7 and 100. It could be 14 and 200. It could be 21 and 300, okay? But however I chosen these values, they need to divide out to give me a 7%. Does that make sense? Or 0.07. When I do that, what's X become? 4. Meaning that angle of inclination is what we eventually are going to call that. That angle that the road makes with the horizontal is 4 degrees. Okay? Which, think about that, it should be small because I'm going to walk 100 feet and I only gain 7 feet vertical. Would you even feel that? No. Okay? So that's, but over, like if you're driving a car through the mountains at 7%, 7% is pretty crazy. I don't even know if there'd be any roads that were 7%. Like 5%, 3% are kind of crazy. We go to North Carolina every year, and there's some roads that are that way. They're like 5%. And I drive a Jeep, and if we're going 70 miles an hour, I take my feet off the accelerator, and we go down a 5% incline, my Jeep gets up to like 98, 99. And that's a little scary. It's crazy driving through those things. Number 22, guys, and 22 and 23. What do you know about a rhombus and the diagonals of a rhombus? They bisect each other, right? They bisect each other, and what do? What did you say, about 90 degrees? They're perpendicular. So if you draw in a rhombus the 2 diagonals, you create 4 right triangles on the inside, right? Those 4 right triangles on the inside are going to help you answer questions 21 and 22. Okay? Your homework tonight up there on the board, where it says, in purple, says 13 through 15, 18, 20, 21, 23, 27. Those are the questions I want you guys to work on tonight. 27 is going to be a challenge, okay? But I think you can do it if you think about it. Don't look at it and say, oh, he says it's a challenge, I can't do it. Put some effort to it, try something. Spend more than a minute or two on it. But we'll talk about those tomorrow, and then, depending on the time that's left over, move on from there. Yes? Huh? Yes.
Can you show 27? Can I take a picture of this?
No. It's a rectangular prism.